This week we discuss Chapter 2, the energy audit process, which begins on page 61 of the text. I've included this PowerPoint file that will be used in the video. I'm interested in your feedback as to whether or not the PowerPoint file was useful or just another way of displaying what was in the book. In Chapter 1, we had some examples of documenting and calculating energy use, which we spent quite a bit of time on. Those examples could be used for reporting and planning. However, little emphasis was put on the segments of the chapter discussing the formation of energy management teams and programs. This was somewhat of an oversight that I apologize for. I've placed a PowerPoint file for Chapter 1 in week 2 of the content folder that you may want to review. So this PowerPoint was adapted from a file from Helena LaRue of the State University of New York, and I thank her for her sharing of this. So in this chapter, we'll determine just what energy is going to be used and how it's being used, and we'll do this in order to make energy reduction recommendations. So as we can see here, the company is going to have to designate an energy manager. Sometimes they won't. Somebody will be responsible for the wasting or saving of energy, depending upon who's paying attention. Quite often, the facility or the maintenance manager may be the de facto energy manager. So an audit is also known as analysis or a survey or some sort of an energy evaluation. So these goals are pretty clear. We want to identify the types and the costs of energy use. We want to understand how that energy is being used or possibly wasted. We want to identify and analyze alternatives such as improvement in operational techniques and or new equipment that could substantially reduce energy costs, or performing an economic analysis on those alternatives to determine which of these are cost effective for the business or the industry involved. So there's 3 phases: preparing for the audit, performing the facility survey, and then implementing the audit recommendations. We're going to cover these in more detail, but here's the outline. So phase 1 would be to prepare the visit. We'll have to get some data from the bills. What kind of energy is being used? Does it vary with time? Preliminary information on the facility is compiled. We'll have to get auditing tools, and we'll have to assemble an auditing team. So in phase 2, we're going to actually perform the survey. That means, of course, let's look at everything. Let's determine what is using energy, and let's try and figure out what can be done to get some cost savings. And the third phase, of course, is implementation. This report may be too aggressive to implement all at once. Most companies that go through the trouble of having an audit done will intend to follow through on the results of this auditing report. But this is not always true. Sometimes companies are only going through the motion to satisfy a customer or a supply chain or just some sort of greenwashing. And they may not have a whole lot of interest in saving energy. I think we're finding this to be less and less the case, however. So in phase 1, we have to get ready for the energy audit. Stuff that we've got to do, of course, get past energy bills, get our geographic location, find out what the weather data is. We'll need to know the facility layout and any construction that has been done or is being planned. We have to know what the operating hours are and the equipment that's being operated within the facility. As we look at the bills, in addition to looking at how much was being used and where, it gives us an opportunity to think about alternate sources of energy that we could consider. When we look at the data in the bills, which, by the way, we will look at more beginning next week. We'll look at rate structures in electric and gas bills next week. It's sometimes helpful to simplify the data. This can be extremely large amounts of information, and getting it into readable and usable formats may be quite a chore. Now, the weather data is it's actually becoming easier and easier to find. We talked about this in last chapter, where we talked about the heating degree days and cooling degree days. So we said that a heating degree day assumes that the desired indoor temperature of 70 degrees Fahrenheit, but there are 5 degrees provided by internal heat sources like people or other pieces of equipment or lighting or so forth. So we're going to use 65 degrees Fahrenheit as the base for computing the heating degree days. In this example, the period of 3 days where the outside temperature averaged 50 degrees F, we're going to see that the heating degree day formula would be 65F minus 50F for 3 days. That would be 45 degree days. Well, I think if you look closely in the textbook, you'll find that quite often we're not going to average it out just into days. We may take it out into individual hours. So lastly, there's this thing that's known as weather data bins. Okay, and a bin is a binary numbering group of weather data. And the good news here is that it's becoming easier to find this kind of information on the internet. A simple Google search will show you both free and for cost examples of where you can get this information. The facility itself. Not only do we need the square footage of the floor, but we also need to know, how big the walls are and the roofs and the windows, and other things to consider might be the directions that they're facing. Are they facing south or north or west? Are there other things to consider, such as prevailing winds that are coming in the large exposed direction of the facility? The original plans that you have may be obsolete, so those might need to be modified or look for replacements. So why would we be interested in the operating hours? It's actually quite important. Sometimes operations require a large amount of electricity, and if it would be possible to shift that to a second or a third shift when off-peak rates were available, that could actually save enough money even to offset the second and third shift wage premiums that are factored in. Here's a pretty straightforward list of equipment that uses a lot of energy: heaters, boilers, air conditioners, chillers, which is a way of air conditioning, water coolers, and specific process-related equipment. It's all going to depend upon the type of facility and what it's doing. Some of the things the audit will be required for the auditor is they will need to quite often make more than one visit. Maybe they'll have to visit during the second and third shifts. Some of the tools: tape measures. We're going to need to know the dimensions. A camera. Things called light meters. Here we can measure things in foot candles. Sometimes they also measure in lumens. One of the things that is often overlooked is what's known as overlighting, especially when previous attempts or previous upgrades were made to change lighting technologies. Maybe we've shifted from one type of a lamp to another light. But we'll be talking about this more in future chapters on lighting. We'll need thermometers, several ways of measuring them, whether with probes or with infrared guns. We also have cameras that can be used, and many of these cameras take not only the infrared photograph, but they can also take a visual snapshot. So with one file, you see not only what the area looks like, because as you can see here on the right-hand side, it's hard to tell what we're looking at. Right above where it says SPI, I can see there's a square opening. Must be some sort of event. And it looks like to the right of it is some sort of a hanging pendant lamp. Hard to say though. But if I had a photograph that was right next to it, that would give me an indication of exactly what I was looking at. Yeah, we're going to have to measure voltage or power. It's really important to make sure that you are adequately trained on using this equipment for both safety and for accuracy reasons. Other things, of course, maybe we're going to need to estimate the efficiency of boilers or air conditioners. Uh, Perhaps we want to measure if there's any leaks. We'll do this with an ultrasonic detector. Um, there are other ways to do it, just simple soap bubbles or listening. Airflow devices. What we see on the right is a blower door attachment. And in this case, we're going to fit that, and we'll see on the next screen that we're going to put this blower door in the facility, and we're going to blow air out of the facility. And we'll measure the rate at which it's escaping. In this case, we would then need to then walk around the building with most of the time a type of a smoke generator. It's not really smoke, or it can be. And we're going to put this near where the suspected leaks are. If we see the smoke moving or being drawn in a particular direction, we'll see that this is an opportunity uh, for, for repair, some sort of a sealing of it. In addition to the safety equipment listed here, there's a good chance you will need to have a ladder with you. Fiberglass works the best. You may want to bring flashlights, coveralls, gloves, knee pads. You never know where you're going to have to go in order to make some of these measurements and take some of these photographs. Safety is always very important. Our safety checklist includes electrical, respiratory, and hearing. And again, I want to point out how important it is that we never work beyond your level of training. Finally, the actual inspection. Pretty simple what we're going to do here. The team will tour the facility, and these are the 9 major systems we'll be looking at: the building envelope, boiler and steam, HVAC, electrical system, lighting system, hot water distribution, any sort of compressed air, specific motors, and then if there are any manufacturing or process systems that need to be looked at. Things you need to be concerned with are, it's possible that some operations are done on a limited basis, only on Thursdays, only at night, once a month. These are things that need to be not only documented, but perhaps visited on different times and days so that you can make sure that you see exactly how the operation takes place. Other things that happen during the second shift are all the rooms, are any lights or heating left on in unattended areas that could be set back. It's not uncommon for extra doors to be left open for ventilation or cooling when supervision is limited. So we're going to need this extra information that's here. All the things that are listed on this page. In addition, it's good to know that there's many times pieces of equipment have built-in time meters that are going to measure the amount of time it was in operation or in standby. And these functions are not always utilized, and it might be a simple thing to go into a menu and have that particular monitoring turned on and reporting made available. So these are the 7 parts of the inspection: the meeting, the introductory meeting, the interviews, the initial walkthrough, gathering of the data, preliminary identification of the energy management opportunities, the generation of the audit report, and then finally to make an energy action plan. So in this introductory meeting, the audit leader will meet with the facility manager or maintenance supervisor to talk about the purpose of the audit, and figure out exactly who is going to be on the team and who will be doing which things. It's important to have representation by several levels of the company, including the general manager, the CEO, other executives, the facility and the plant manager certainly need to be there. It's good to have the finance officer there because they're the ones that know what these horrendously large bills are that they're required to pay. Floor supervisors, equipment operators, maintenance people, maintenance crews. It's just amazing where you will find the information that you're needing. During this interview, we need to make sure we write down the names of the people and all their contact information, and find out if these people serve more than one function. On the initial tour, we'll gather the information that's listed here, and it notes that a second visit may be required. Quite often, the personnel are going to act a little bit differently when the boss is around or when someone's there that's not normally there, and so they may not do things the exact same way, which could skew how the data is collected. We went through this before as far as the 9 major systems that we're going to look through. You can look through this again if you want. And each of these 9 systems have these questions to ask. What does it do? How does it do it? Does it use a lot of energy? What sort of indications would be there if the thing wasn't working correctly? How can we make it work well again? Is there a way that energy costs could be reduced? Who does the maintenance on it? And who has the responsibility for maintaining and operating and the overall efficiency of the system? So there are forms that are available from many places that we could get the information even before we walked in. If we knew what boiler it was, we could get their specifications and actually have that before we started the meeting. Some of this is available. They list here the National Electrical Manufacturers Association, also known as NEMA. I have no idea what this guy is doing in this photo. The building envelope. It's not unlikely that doors and windows are left open, and maybe they'll get closed during the inspection because the boss is around, and then when everyone's gone, these things could be opened up again. Delivery doors are also quite suspect for having leaks because they're open and closed so often, or for being left open because we know that the delivery guy is going to be here any minute. Why should I close the door again? We'll talk more about this in chapter 6 and 11. The boiler and the steam system is, again, it mentions here at the bottom, we'll talk about this quite a bit in chapter 7 and 8. They describe the differences. One makes steam, one makes the boiler could be used to make steam or hot water. If it's only making steam, then motors aren't required to distribute the heat being carried in the steam. If it's a boiler that makes hot water, that water needs to be pumped around. It can't just be heated. So 2 different distinctions here, and we'll talk about that in chapter 7 and 8. This information that's listed here is going to be required for almost every piece of equipment that we talk about here. We need to know what it is, what size, any sort of model numbers, any sort of age, how long has this been operating, what kind of fuel does it operate on, could it be operated on a different kind of fuel. We have to look at the condition of it. Has it been adequately maintained? Does it require a lot of maintenance? It could be that things that are old and inefficient might be prime suspects or prime opportunities for being replaced with newer, more efficient, more reliable equipment. The electrical system itself, this is not including the lights, right? This is just moving the electricity from where we're getting it from the meter to where it's being used. Sometimes there will be transformers that are owned by us or owned by the facility, and those transformers have levels of maintenance. Quite often they're looked at as though they're just magical. They don't really know what's being done. It just sits there and hums and is warm, and you don't know if it's working correctly or not. Whether it's the equipment hooked up to it is working or not, it might be shut off, but if the transformer is still running, it still has power going to it, even though the equipment connected to it isn't turned on, there's still energy being used there and quite often lost. So be really careful when you're looking at these, especially in the older equipment that perhaps you don't know as much about. Hot water distribution system. Pretty clear here what's listed. Again, the same kind of stuff. Who made it? What size? Model number? How many are there? Where are they used? And I really like the photograph here. We can see that it's a very nice facility, and we can see that all the piping is insulated, and it looks like a good facility. As far as lighting and reflective surfaces, we have 2 chapters in which we're going to be looking at this, in addition to the chapter 14 on renewable energy. There's been a lot of activity on changing over to more efficient sources of lighting, LEDs and compact fluorescence over the standard incandescent lights. Air compression systems are quite often huge opportunities for energy management opportunities. Quite often you'll have a leak near a piece of equipment that has a built-in leak. When it's operating, air is going through and it's doing some work and it has to be exhausted. Well, while it's exhausting, we may not notice that there's also another noise present that is an unintended leak. And these, as we'll see later in the book, can add up to some significant losses and costs for the company. Motors, oh my gosh. So notice here, motors over 1 horsepower should be inventoried. Again, same sort of information that we need to save for it, that we need to record for these. It's something else that isn't often realized is it's not uncommon for motors to be oversized for a job. Maybe a 3 horsepower motor would work just fine, but instead a 5 horsepower motor is put in place. We'll talk later in the book about variable frequency drives, which are going to reduce energy use with motors significantly. Manufacturing processes, these might be some of the tougher things to do because we don't always understand what these processes are. Some of the ones that are listed here: chemical reactors, combustion for direct heat, furnaces and kilns, direct motor drive. So careful analyzation of these pieces of equipment and what's been being done with, for example, the exhaust heat from a furnace or a kiln. Could we use that someplace else in the facility? Whenever we make our reports, we want to be able to find out which pieces of equipment are using the most amount of energy, because these are the ones that are going to have the most potential for energy savings. So now, once we've got all of our data put together, we've collected all of our data. Now we need to put it together to make some sort of a report that's going to make sense. And at the beginning of this is going to be the executive summary, which might just be the only page that top-level management reads. So you need to make sure that that information is clear and concise and gets to the point. There will be examples later in the book. We'll actually put together one of these reports and we'll study one. And so again, we have to have an introduction. We have to describe the facility and all the equipment. We have to analyze the bills, list possible energy management opportunities, and not only what it could save, but how much it makes sense. Yes, it might save us, $10,000 a year, but how many years will it take to recover that savings? The investment in that may not. The investment may outweigh the potential savings. So we have to come up with a plan based on all this data that we've collected and make some sort of a conclusion that wraps everything up. Our third phase is implementing the audit recommendations, which of course means that the company's had a chance to look at your recommendations. They've read the report. They've selected the goals that they have, and they're ready to initiate some action. We have to remember that the company's goal isn't just finding a way to reduce the amount of energy they use. They're selling widgets, or they're making things, or they have some other function there, and we have to make sure that our recommendations mesh well with their company goals. So they will have an energy action committee, and this committee, hopefully, will have stakeholders in here, and those stakeholders will determine, based on the proposals and the data that's provided in the plan or in the audit, they'll figure out exactly which direction they want to go. Well, who should be on this committee? Well, we should have management there. We should have people from finance there. We should have people from operations there. We should have maintenance people there. They're going to look at the cost, long-term payback, effects on production, effects on how people are going to be affected by doing this work, where the ideas are going to come from. They'll have to set the goals and determine whether and where they'll implement the changes. And then finally, of course, we have to be able to monitor the results. So the goals. Is it a performance goal? They want the equipment to use this much less energy. Is it an accounting goal? Maybe there's a way to change fuel sources and be able to pay for a lower fuel cost. How much participation will be required by the employees? They're busy doing other things. Will they have time to do this sort of work? One thing that we can do, we want employee participation. Sometimes a reward system or contests can be beneficial to improving participation. Again, we have to remember that it costs money to do these things. We have to monitor and make sure that what we're attempting is working. And we must always remember that the participants will have primary jobs, and management support is going to be critical into getting these extra assignments completed. Monitoring has to be done to make sure that we're meeting the goals. Perhaps our goals were too high. Maybe they were too low. Maybe we're not collecting the correct data and the feedback isn't right. So we have to keep an eye on this and not just expect that it's going to work or not work. There's ways that we can monitor. One of the ones given is an example known as Fat Spaniel, and Fat Spaniel is a type of it can be customized to a variety of pieces of equipment. We've seen it quite often used with wind and energy equipment. Other manufacturers of this wind and energy generation equipment have their own proprietary monitoring, and almost all of these are available via the web. So this is changing very rapidly. So we have to have a very dynamic process here. We have to be able to analyze the past data. We have to look at the systems that are being monitored to make sure that we're not overlooking something, and basically keep an eye on the whole system. There are certification programs available for energy management people. I've got a couple of them listed here. More are out there. When you go to these websites, you'll see that there's training available from there. There's exams, there's practice exams that can be taken, and some of them will even have places that list employment positions. So that wraps up this chapter. I hope that this is going to be beneficial to you.